Well, hello there, and welcome to this video. In this video, I will show you how Mr. Helpful works, how you could build him yourself, and yeah, all the models will be linked down in the description in the link tree in my makerworld account. And feel free to edit this model, because in this current point of time, Mr. Helpful is just made so that he's more like convention ready, but we will talk about this in just a bit more detailed. And yeah, therefore he's pretty power hungry, but yeah, whatever. Feel free to edit this model and let's get right into Fusion 360. So this is Mr. Helpful's full completed model. Like I said, he was made in a way that he's more convention ready, so there are a few considerations to make for that. So let's start from the top and go down to the bottom how it works. If we remove the hat and the back of the head, we will see the hole where the speakers are placed inside of here. So it is more natural that he can speak because it goes directly out of his mouth, the sound, and not from anywhere else. And yeah, here's also the routing channel where we route the cables from the speakers down to the basement. So yeah, and if we remove the head, like this, we can open up the hatch, the front hatch, which is attached via 4 magnets, so it is easily to open up while you're at a convention or whatever, or you need quickly to open him up because something happened or whatever. So yeah, the 4 magnets are placed here in 1, 2, 3, 4 holes. And yes, so here we can see it is pretty cramped inside of here because we do not have much space. It is a 1-to-1 replica, and therefore there were a few considerations to make since I wanted to be a bit more convention ready. So how it works, how it moves is by going with servos. With 20 kilogram servos, so they are pretty power hungry, and 8 of them in total. So yeah, pretty power hungry. And yeah, and he works by springs, by compression springs. So his arm and everything move by springs, and with a pulley system. So the servos, how we can see it here, have a pulley system where a fissure line is placed inside of here and is routed through the channels. Then, like we can see it here, and on the other arm also. And yeah, so since we use fissure lines and springs, he's a bit more wobbly, which is good because in his in-game, if he moves, let's say he does a pose, because he moves, he stops for a few seconds and then moves again. So if he does a pose, he wobbles after it quite a bit. So his arms, his body, his ears, everything wobbles or wiggles. And yeah, so therefore it is good with springs. And springs are also good because if it's permanently attached on there, so springs cannot break immediately, like with 9-gram servos. Because I could use 9-gram servos in these, but let's say we go around with him and we bump into other people with his little arms, or let's say into some obstacles or whatever. It could lead that 9-gram servo, because 9-gram servos are pretty small, but can easily actuate the arms and everything, but also are pretty fragile. So if there's a sudden movement or something, or let's say we bump into things, it could lead to that it breaks internally. And this is really bad. So therefore we use the method with the springs and the gears, with the springs, gears, and with the pulley system, because gears are in the bottom, but we will see it later. So yeah, let's look at the arms again. So the left arm, from his point of view at least, so this one right here, can move forwards so in this direction right here, and the right arm also, but the right arm can also move upwards. And yeah, because it is pretty cramped inside of here, so we could only use 3 servos in total right now. And yeah, so these 2 servos are for the right arm, and this back servo is for the left arm. And yeah, later on this so in the slicer I've cut just this part out, so I've attached it manually with magnets, not in the model directly. So yeah, then I can easily get to the back servo. And yeah, so let's remove the arms and everything. So now I've removed everything else, so we can look a bit more like internal. So his whole upper body is supported via bearings and also via aluminum rods. So he's pretty stable on there, and the weight is not going directly on the springs or whatever, but is mainly going through the 3D print and also through the rods and everything. So yeah, here are the holders for the bearings, and also here's on each side of the 3D print is a mount for a mounting hole for the rod. This is going through there. So, and if we remove this one, we can look at the lower structure. So here are the routing holes for the left and right movement. So if he leans left or right, so these are basically the mounting points for the springs also, but also like the routing points for like the fissure lines that are going through here and down to the bottom, where we can see right here the servos for it, left and right. And yeah, so let's remove the leg. Now this is also right here a mounting point for a spring. So for if he moves basically forwards or leans forwards or goes back a bit or straight, then these are the mounting points or routing holes also for the springs and for the fissure lines, which are going down. So yeah, and here's also like again for the bearings, the mounting holes, and internal in the model there are again the 2 things, the 2 mounting holes for the aluminum rod. Oh yeah, and also for the rod, in the slicer I just said let's make it in 3 parts. So I split the model right here in the middle, and then on the top. So I first assembled the left and the right side, and then the top on the yeah. So yeah, let's go even further down to the bottom. So this is the basement where everything happens, from controlling it, managing the power and whatever. Yeah, if we open the base up, let's see. So we can see here the internal structure. So here we have the cells. In total there are 4, but I currently removed 1 that you can look at it a bit more clearer. So this is directly cut out for the 20 kilogram servos. But yeah, feel free to edit it if you want to use other servos, because yeah, we could use also 9-gram servos, but yeah, it is then easily more fragile then, and I do not want it to be fragile. So yeah, this base is basically attached to, where is it again? So here you can see it a bit clearer. So this part right here, the upper part, is attached to the lower part with a ring, so press fitted in there, and then also inside the press fit I applied epoxy glue, so it is literally bonds together forever. And yeah, if we remove the ring, we can look at it a bit more clearer. So this the lower part exists of two parts, and the right and the left side. which are attached together via these holes where there are bolts and nuts going through that, so it's really on there. So yeah, these are the servos, and here we have also the lower part that he also can rotate left and right, his whole body basically. It is attached via a giant ball bearing, which is in total, I guess, 100 millimeters. For a ball bearing, it's pretty big and not that easy to get. But yeah, I got it and it works. So yeah, it is directly cut here out, 100 millimeters, that it is basically perfectly fitting inside of here. And yeah, and this 8th servo is basically for the rotation, so left and right, so that he can lean, not lean, but move left and right, his whole body. And yeah, so yeah, and in here is then placed a Arduino Mega, which is controlling all of these with a Arduino servo shield or a sensor shield. And then all the servos are currently attached then to a industrial or better said automotive voltage converter, which converts the ingoing voltage to 5 volts. And yeah, and so, and therefore it is long lasting and whatever. And on the back we have here 3 holes, one for the power, one for the cable routing that goes out here, because I used an IR emitter and little remote that I can easily say I can program each animation for a button. And yeah, and then this third hole is for a attachment for a second speaker, so for an audio jack port. And so if you think he isn't that loud enough, then you can theoretically attach a speaker externally again. But yeah, this is how Mr. Helpful works in total. And yeah, like I said, feel free to edit this model, because in this point of time he's pretty power hungry. So I used a whole power station, which is pretty heavy, and yeah, and he has, over just one convention day, he has definitely quite eaten a bit of power. So yeah, he isn't that efficient in power wise, but he is definitely convention ready, because he survived everything. And yeah, so yeah, this is how Mr. Helpful works in total. And yeah, feel free to edit this model, and I would say we will see you in the next video, or maybe even a little teaser for a new reveal. So yeah, then I would say